we want to find the volume of the solid of revolution formed by revolving this rectangle, the purple one, around the y-axis. So spin. When I spin this thing around the y-axis, it's going to make a three-dimensional solid. It's going to look like a cylinder with a hole in it. And I guess a real-world object could be like a roll of paper towels, roll of toilet paper if you want. All right, so let's kind of sketch a picture to go along with this. So I'm going to draw this large cylinder. And then I'm going to draw the little hole that's going to go straight through this thing. Oh, that was terrible. Okay, and then I'm going to finish this thing off with the rectangle that actually is spinning around this thing in order to form it, and then maybe color this in nicely. So this purple rectangle that's right here is the same purple rectangle that's in the picture on the coordinate plane. There we go, good enough. All right, let's label some dimensions on here. So the smaller radius that's right in here, the smaller radius, that's 2. That's the radius of the hole. Now, just to make this really clear, I'm going to make this y-axis that we're spinning this around red. I'm going to put that same axis in here. So there's the axis that we spun this thing around. So this little 2 that we just found, that's this inner radius here. Okay, and then the outer radius for the big cylinder, that one is 5, just taking that directly from the coordinate plane. And we need one more piece of information. We need the height. So you can see that there are 4 boxes high. What the heck? Okay, whoops, sorry. Technical difficulties. It is 4 high. All right, so now we have enough information to find the volume of this solid of revolution, and we've got a couple of things that we could do. We could use that general volume formula, which is the area of the base times the height, where our base is this circle with a hole in it. And in order to find the area of a circle with a hole in it, we just subtract the 2 areas. There we go. It's like a Fruit Loop or something. Grape. Okay, so if we're going to subtract these areas, we need each of the radii, which, let's see, that radius, the inner radius we said was 2, and then the outer radius is 5. Whoops. Okay, 5. So the area of the base should be big circle, which is pi times 5 squared, minus little circle, which is pi times 2 squared. We get a 25 pi minus 4 pi's give us 21 pi. Pretty sure. All right, so we could take this volume and make it 21 pi and then multiply it times the height, and we said that our height is 4. So 21 times 4 gives us 84 pi, and then throw some units on there, units cubed. Okay. Now, let's say that we didn't do it quite like that. Let's say we did it as in, hey, it's a cylinder with a hole, so I'm going to find the volume of, let's maybe divide this up a little bit. Maybe I go, the volume is equal to the big cylinder minus the small cylinder. And we should get the same exact answer here. So let's see. The volume of the big cylinder should be pi times our radius. Our radius, big radius, is 5. I'm going to square that and then multiply it times our height. Our height is 4. And then subtracting out the small cylinder as the whole from this thing, pi inner radius was 2. I'm going to square it. Also has a height of 4. All right, here we got 25. 25 times 4, we get 100 pi minus 4, or 2 squared is 4. 4 times 4 is 16, minus 16 pi. And if we take away 16 from 100, pretty sure, we get 84 pi. Let's see, yep, that sounds about right. All right, so any way you shake it, still comes out to be 84 pi units squared. If you want an approximate answer, I'm sure you have access to a calculator someplace.